The big thing that Netdata has is flows. So apart from network topologies, we have also implemented the ability to collect and visualize network flows. I'm going to show you this here, I think. I'm going to go to flows. Now, this is network flows, meaning that Netdata is an ingestion in a database for network flows. It listens for NetFlow, sFlow, and IPFIX. NetFlow 5 and 9, sFlow, and IPFIX is actually the NetFlow 10, let's say. So the idea is that this is a separate Netdata plugin. You have to install it yourself. It's not installed with Netdata. When it starts, it automatically listens for these protocols. It has its own database. Its ability to ingest is about 100,000 flows per second per installation. It writes the files to journal files, so you can the entire database of logs or flows. Of flows is in journal files. So you can use journal.ctl to query them. You can also integrate them with your CM or whatever you want, mainly because it's journals. This has some interesting views. So the idea with NetFlows, for those that don't know, is that flows are emitted by routers on a per interface basis. So you have flows that the router emits for everything that goes through a network interface. Mainly because this is routers, it means that all the flows are emitted twice. The router will have something, receive something from one interface and send it from another. This means that by default, if you don't filter, if you don't slice this on a single network interface, most likely you are seeing all the traffic twice. Inbound in one interface, ingress in one interface, egress on another. Now, the idea here is of NetFlow is to find out who are the top talkers. So one is top talkers, who consumes my network, who does most of this work. You can, of course, slice it and get the top talkers for whatever. I can say, who are the top UDP talkers? Who makes most of the HTTPS traffic? Who makes most of this traffic, or whatever? So top talkers by any filter you like, but also is about finding the needle in the haystack. So I want to know what this server is doing, all of it. Or I want to know only these three servers, what they are doing. So the idea is that of NetFlow is to provide a user interface that allows people to slice the data the way they see fit, and once the data are sliced, to actually find the top things that are happening there. Now, Netdata has this visualization here for NetFlows. It is this plugin, so you go to live, then you have this menu. These are Netdata functions. In flows, you have NetFlow. Now, what we see here, the first is a Sankey visualization. This visualization is totally dynamic, so I can rearrange the protocol. I can do, or I can add more fields. Actually, you can add as much as 10 fields there. So I can go here, destination IP address. You see, it came. I can rearrange them. So the idea is that you build with up to 10 columns here. You can build the slicing that you want. Now, what we see here is this random selection is the source autonomous system protocols. So you can see by protocol. You can see then destination IP address and then destination autonomous system. Now, let me remove the IP address because this is not very useful for that thing. The next thing is that I can filter So you can say here, I want source IP. So the source IP address, I want it to be, let's find the server that we were looking before, the inference server, 10, 20, 4, 21. So this one. Now, this is the traffic of that server only, because I selected source, its own IP address. Of course, is what this server sends. Now, you can see where it connects. It connects Cloudflare Net, Google, GCP, Alibaba. Probably this is because of light LLM. So it connects to Quen models, etc. So the idea is that you limit how many of these you want to see. You limit it here. So the top tokens, how many top? You can go up to 500. Of course, the graph will become ugly at 500. It doesn't have, let me remove this IP, because this doesn't have so many tokens. So if I go here and I select 500, of course, it's going to be ugly. Now, you can see a table, you can export the table. So we have filtering, Sankey visualization. Now, what you can do is get a time series out of this. So I can see this data over time. And this means that with the grouping that I have done, again, we're talking about the top tokens, all others will be in others, because you select how many top tokens you want. So the idea here is that you can get a time series of this, see a country map. Countries maps are more beautiful in 500. That's better. And now the intensity of the link, so this link has more bandwidth, like the others. Now, what happens here is that we have one link per related country. In state, we have per state. So you can go here and see that US, for example, it's states. This states thing happens everywhere. So you can go to Greece and have states. Something is there, some aggregation point. So everywhere it works per state. You can go down to the city. And this is the most interesting part. In city, especially for the US, mainly because the guys have open data. So here in San Francisco, for example, you can go down to the individual data. This is obviously an AWS data center. And you can go down to the data center, the specific data center that hosts your infrastructure or that talks to you. So this globe is about now seeing the data in a sphere, on Earth, so you can understand where you talk in a more appealing way. So you can switch here the visualization, you can make it night, like this, like this. I love this, to tell you the truth, the dark, because it highlights all the endpoints, and of course you have with borders, so you can see the borders. This is the city data appear here. So that's very nice, because you actually have at the city level what happens. And of course on hover you can see even also on the cities. Where is it? There. Come on. There. So this is about NetFlows.